Mystic ancient secrets can all be answered when you ask the mystic access guru. That is I, the great exalted one. I have come across 3 astral projections through the god plane in the hero metamorphosis to give you the knowledge you deserve.
Hello, guys. Here we have here Cygnus, Mr. Matt Bat. Greetings. Good to have you here. And yeah, so we've got Brian's Logic posted a video today, and of course he fucking gets everything wrong. So let's watch. It's about a half an hour long.
Well, how are you doing? Okay, this is going to be a video about how an elevation angle is always a right angle triangle. Right, people?
No, an elevation angle is not a right angle triangle, dummy. No. See, an elevation angle is an angle. It's not a triangle. It's 1/3 of a triangle. So what are you talking about? And there's no lines on an elevation angle. They are rays. They are points in space in line with your eyesight.
Are very confused out there. Surprisingly, on the flat earth side, not just on the globe side, they don't seem to realize that an elevation angle is called an elevation angle because the right angle triangle that it is pre-assumed.
No, it's not. But, you know, if you want to get a distance from the zenith of this thing, then you have to know the height of it. Did you know that, Brian? You obviously don't.
You don't. It's like you don't buy a Volkswagen Passat and expect someone to tell you at the dealership that there's wheels on it. You know there's wheels on it. That's what a car has, right? It's kind of like that, right?
Hey, Stanley.
The thing is this: if the elevation angle was just an angle, then it wouldn't be called the elevation angle.
Why? Why? You're measuring an angle to something that's above another thing, like the horizon. Why would it not be called an elevation angle if it's measuring the elevation of something? You're dumb, man.
This here, right? This is the elevation.
Hey, Westside. Yeah, it just started.
It doesn't matter if you measure it in degrees, if you use the units of inches, feet, miles, kilometers.
What? Degrees or inch? No, you don't measure in angles in degrees or you don't measure in angles in feet at Jesus Christ, Brian. What the fuck are you talking about?
This here, right? This is the elevation. It doesn't matter if...
Yeah, that's the elevation. That's the height of this star or this point.
If you measure it in degrees.
You don't measure the height of this in degrees, Brian. You don't. You measure the elevation angle in degrees. You don't know how far this thing is from you. So you don't know where on this line of sight it's going to be. You don't know this. Therefore, you don't know this. Therefore, you can't know this. And you don't know this. Therefore, you can't know this.
If you use the units of inches. Feet,
hey, Citizen 9.
Feet, miles, kilometers.
Hey, Lindsay.
Meters, makes no difference. The point is that this is always, whether it be altitude or elevation, whichever way you want to describe them, both of them are straight lines. So...
No, there's no lines, Brian. There's no lines.
Someone's elevation, if they're on a mountain above sea level, is their elevation, right? That's a straight line above that point at sea level, directly below them, right? So if someone's elevation is, while they're standing up on a mountain, is 6,500 feet, then that means there's 6,500 vertical feet above that point at sea level, right? Mean sea level, whichever, right? The same for altitude. If a plane is at 38,000 feet, then its altitude is 38,000 straight line vertical feet above mean sea level. Yes,
that's correct, Brian.
What it is. these things are not curves. They don't curve because you're using the arc scale.
What? They don't curve because you're using the arc scale. What are you talking about, Brian? What are you talking about? Nobody says that lines curve. Nobody, man. Hey, George.
That doesn't change anything. They're still straight line, right? So a lot of people don't realize this, right? They think that because you must invoke, or they think that you must invoke a zenith angle, right, after you've measured your elevation angle to gain the distance along the adjacent, right? And
What? Measure a zenith angle? Before you... What the fuck are you talking about? Your zenith angle is always 90. It's always straight overhead, Brian. You don't measure a zenith angle, and you don't measure the zenith angle of this thing from here. What the fuck, dude?
they think that means that the elevation angle is not a right angle triangle. Some of them think that is why it's not. But they're
No, an elevation angle. See, this is the elevation angle. It has nothing to do with this or this, Brian.
wrong. It is a right angle triangle. You don't need a zenith angle at all,
Hey, Moxie.
as I will show, right? I have here from this point, which is 0, to this point, which is 5,400, right? 5.4, it's 5,400. So imagine that to be 5,400 nautical miles, right? From
Okay.
this point here to this point here, right? Now, if we, and I have a 36-degree angle here, so, right, how do I determine the length of my adjacent without the zenith angle? Very simple, right? I measure my
No, you do not know. Your circle of equal altitude is what you're measuring here. You don't know it without the height of this, without the height. You can't determine it. You can't. You can't use 60 miles because that's Earth curvature miles, Brian. That's Earth curvature miles.
my angle will be 36 degrees. That would be 90 minus, right, 36. Oh, sorry, that's 36, right, which is my angle, and I'll multiply that by 60, which will give me
Why? Why, Brian? Why are you using Earth curve math? Why are you using heliocentric math, Brian?
21,600, right? All I do then is, right, subtract.
So, and one more thing, Brian is using Muppet vision in his illustration, in his example here, which is forbidden for the flat Earth, right? You can't use an orthographic view, right, Brian? So you're just blowing Nathan Oakley's game here.
Right, 5,400, 21,600 from 5,400. So then so 21,600. Oh, what am I doing? Sorry, I'm doing this wrong. 54,000, right? Minus 2160. Sorry, 2160. Sorry.
But see, on a flat Earth, you have to know the height. You can't use 60 degrees per mile. You can't use that, Brian, because that's a curved Earth measurement. See, on a flat Earth, it doesn't equate to 60 or 1 degree per 60 miles. It doesn't work on a flat Earth. I've proven this. So you have to come up with some other measurement, Brian, some other way of measuring. See, on a flat Earth, you have to know the height of the star. That is a prerequisite, Brian. Unless you can prove that, unless you can do that, then you lose. You fail.
Equals 3240. So how did I gain the length of my adjacent without the zenith angle? Very simple. I just multiplied 36, my degrees, my angle degrees, which is 36 degrees, by 60, and I subtracted that from 5400.
Okay, so Brian, if I measure the angle to the top of my wall here at 45 degrees, and I multiply, I subtract that from 90, right? And then I multiply that times 60 miles. Let's see what's 45. So 45 times 60 would be, or 45 degrees. So that would be 4.5 or something like that. 45 times 60, which would be how much? So you're telling me that 45 times 60, that my wall is that far away that I can see and throw shit at? That's how far my wall is, Brian? Because the bottom of the wall would have to be that many miles away for your logic to work, Brian.
That's exactly the same thing. You don't
Yeah, he subtracted miles from an angle.
need any zenith angle, right? So that gave me this length here, which is 54, which is 3240, right? So as you can see, right, 3240. So that means my adjacent length here is 3240. Now in celestial navigation, that's all they're looking to know. They're not looking to know any more than that. That's all they're looking to know. But my point is,
What? In celestial navigation, that's all they're looking to know? No, Brian, I'm sorry. That's not right. See, in celestial navigation, the tables that you use to get a sight fix or to get a sight reduction all use heliocentric math, Brian. They use curved math, math that only works on a globe. So you citing or referencing celestial navigation proves that either you do not know anything about celestial navigation or you're a fucking liar, Brian. Which is it?
you don't need any zenith distance or zenith angle to determine that, right? So what's happening is it doesn't matter if my angle is 30.
See, in celestial navigation, all you need is the time of day, the exact time of day, a angle that you're looking at, and an angle above the horizon of the celestial body you're sighting to. That's all you need for celestial navigation, and you put those through the tables, and you get your result. So you don't know what you're talking about, Brian. I mean, that's not all you That's not all you need. Those are all the measurements you need for doing a sight reduction, and you do it You do it with different stars, so you get a triangulation or a trilateration.
46 degrees,
Sorry.
84 degrees, or it's 11 degrees, which would put.
I know how it works. I just haven't gotten around to learning how to do it yet, right? I know how to paint a picture. You put paint on a canvas and you have a picture, but I don't know how to do it so it looks good yet. Same way as with this. I know the steps you need to go through. I just don't know how to put that into practice.
Put this
I haven't learned yet.
celestial body here, let's just say, with I would change the length of this down to something equivalent to something here. The point being is that as you're like literally, they're simultaneous because you're measuring the vertical, you're measuring the altitude, you're measuring the elevation, so you're measuring the vertical. You can't deny the vertical, which is the opposite of the right angle triangle. You can't deny the opposite and still measure the vertical. You can't do that. You can't deny the opposite and measure the elevation because that is the vertical.
No, you don't have, in an elevation angle, you don't have this. You don't have this. You don't have this. You don't have this. You have this ray, and that's it. This angle. That's all you have, Brian, in a flat Earth celestial navigation. You don't know how far you are from the star because you haven't measured the height of it. You'd be lost at sea 5 miles from shore, man.
You can't deny the opposite and measure the altitude because that is the vertical. So you can't deny,
And on a flat Earth, in the northern hemisphere, you can't get a latitude fix. You can't get a latitude. Not on a flat Earth. Not on a flat Earth.
when you're denying the elevation or you're denying the altitude, you're denying the vertical, which means you're denying the opposite of that right angle triangle. The reason it's called an elevation angle is because you're measuring the straight line elevation.
No, you aren't measuring that elevation. You're measuring the apparent elevation above the horizon, Brian. This thing can be right here, and it would still have the exact same elevation angle, Brian. But yet, is it this far above the ground? No, it's this far above the ground. Or it could be out here. It would still have the same elevation angle, Brian, but yet it would be way further away. Until you know this height, you cannot determine this distance. Not on a flat Earth.
Right? Or on solar, sometimes it's called a solar or celestial altitude angle. Same thing, you're measuring the vertical altitude. Right? Now, obviously, with a celestial body, they don't behave like a mountain or a light pole or whatever.
He's just saying a bunch of words, Citizen 9. He's just saying a bunch of words. They don't mean anything together.
So you can't, a building, whatever, you can't, so whatever height that you get to them is not their actual height, right? Because they don't behave the same as terrestrial objects. They're celestial, some things, I don't know what they are, but I know that they don't behave like terrestrial objects, so they don't, you can't say the height of this celestial body. If we base it off of the adjacent here, we can't say it's 2,354 miles. We can't say that.
You have to, Brian. You have to say how high it is to get a angle or a circle of equal altitude. You have to know that, Brian. On a flat Earth, you have to fucking know that.
Just because this is 3,240 miles. But its apparent height at that moment, right, is 2,354 miles. That's its apparent height, right? And the apparent length of the hypotenuse is 4,004.86 miles. That's the apparent one. Obviously, because it's a celestial body, right, in 10 minutes' time, it will have a different height, even though you're in the same place.
Right. That's because, well, it won't have that much of a different height. 10 minutes later, that's 1/6 of a mile, or 1/6 of a degree. Or no, 10 minutes later, 15 degrees per hour. That's 1/6 of 10 degrees. Echo, what is 1/6 of 10 degrees?
1/6 of 10 degrees is about 1.67 degrees.
So 1.67 degrees. So that's how much it would change in 10 minutes,
That's right,
Brian.
Sean.
Echo, stop. So that's how much in 1.67 degrees. So that's why you record the time, Brian. That's why the tables, the site reduction tables, have times listed. So.
But the same, right, it will have a different apparent height, I should say, even though you're in the same place. Let's just say if that's moving away from you or moving towards you or whatever, right? Same is true though, if that was like Polaris or whatever, and you moved away from it 10 minutes later, you're going to have a slightly different angle. Do you know what I mean? It depends on how far away you move. And then it's going to have a different apparent height. But that doesn't change the fact that as you're starting to measure, whether it be 1 degree, 4 degrees, 12 degrees, 36 degrees, you're instantly, as the measurement is happening, the whole triangle is basically, if you take this celestial body, bring it straight down to this point here, right? The whole thing is just a straight line, right? It's just flat. What would happen is that if you bring it actually more down to this point here, right? The 5,400 point, right? It's like, imagine this.
Why are you bringing it down to here, dude? Why? Why are you doing that, Brian?
This is a pole inside a tent. This is a pole that as the angle increases, the pole, whether it be goes from 0 to 1 degree or 8 degrees or whatever, or 24 degrees or up to 36 degrees, that pole increases in length. And as that pole increases in length, this length here shortens. As that pole decreases in length.
Say what? As this increases in length, this gets shorter? No, Brian. That's the exact opposite of what happens. As this increases, it has to stay on this line, Brian. It has to stay on the same line of sight. As this pole increases, it would have to be moved away. Therefore, it would be longer, Brian. What the fuck are you talking about?
Right? This length here lengthens, I should say. But the point is that this right angle
He's a complete fucking moron.
is always there. You have this angle here, this right angle here.
No, Brian, these lines are made up. These lines are made up. They don't exist, Brian. That's why there's no lines in an elevation angle. You have rays. You have a ray of light that goes from that thing to your eye and that thing to your eye. It's called rays. There aren't lines, Brian, and they don't make up a triangle.
Here and this angle
Fuck
up here.
me.
So if this is 36 degrees, this has to be 54 degrees because that's always 90. Because it's an altitude, as an elevation you're measuring. So that means it's a vertical, so it's always 90 to the horizontal. So even if it's 1 degree, right, that you measure your angle to be, then you'll have a very small vertical over here, right, and a very long hypotenuse. But the point being is that you're still, as soon as you're away from zero, this is automatically employed. It's automatically created. It's part of it.
No, it's not, Brian. It's fucking not. You're a dumb shit.
Of the elevation angle. It's why it's called an elevation
Jesus
angle.
Christ.
They didn't call it the elevation right angle triangle or the elevation triangle because the triangle.
Right, because it's not a fucking triangle, Brian. Mathematics doesn't call something because it assumes something else. Mathematics is pretty fucking specific with its language.
Is employed within it if you understand it. The same way as no one has to tell you that your new car comes with wheels. Of course it comes with wheels. It's a car. It can't come without them. The same way as you can't measure this elevation angle and ignore it.
Right, but let's say you've got something that requires wheels
as being.
You don't assume it has them. Right? You don't have... Jesus fucking Christ. It's like talking to a goddamn gerbil.
Right angle triangle. That...
Hey, Debatable D.
Cannot be done. It is always a right angle triangle if it's only a quarter of a degree of measurement, or if you've measured it to be 87 degrees, it makes no difference. All you're doing is changing the length of the vertical and the distance of the horizontal. And of course, the length of the hypotenuse. But that's all you're doing. You're changing these three lengths, but you're never changing what it is. So it's not a case of you measure just some angle and then you turn it into a right angle triangle. Or like the ballers do, idiots. They ignore this part completely. It's like, now I'm sorry, if you're a flat earther and you're ignoring it as well, then you're being an idiot. Because if you're ignoring this part or you're denying the opposite, you're denying the elevation, you're denying the altitude, you're denying the vertical. Which means you're not, it means that you're claiming you have a horizontal line. Because you don't have any measurement of anything. Because you're not measuring anything if you're claiming the thing that you're measuring is not there. If you're claiming the thing you're measuring doesn't exist, then you're not measuring anything. You're measuring the vertical, that's the point. So at all times, as soon as you start measuring this angle here away from zero, right, it's instantly a right angle triangle. Because it's an elevation angle. There's no if, buts, or maybes about it. You can't get away from it. It's always got a 90 degrees to it. It's always got two angles. That's three angles. That's a triangle. As I said, they don't call it an elevation triangle because.
Right, because it isn't, Brian. If it was a triangle, they would call it a triangle. They don't call it that because it's not that. Jesus fucking Christ, you're dumb.
It's implied that it's a triangle by the word elevation angle.
No, fuck me. Holy shit. Holy fucking shit.
You're determining a distance. It doesn't matter if you do it in the celestial navigation way or if you do it in the ways that they would do it, like with a surveyor would do it or whatever, with a mountain or whatever. It doesn't matter, like using just the angular size of the object, the known angular size or the known
God, he's dumb. Holy shit, he's fucking ignorant.
distance to it, blah, blah, blah.
Yes, dumb as fuck, Cygnus. Absolutely.
It doesn't matter which way you do it. It's the same thing.
And he thinks he's educating people. That's the funny thing. He thinks he's educating us idiots. He thinks he's educating people that actually know how to do celestial navigation. And if they're watching, he actually thinks he's educating people who've been to space.
I can take away these three lengths right here, right, and just have just pure triangle, right? And with 90 degrees, 54 degrees, and 36 degrees, it's still a right angle triangle. Makes no difference. It doesn't matter, right? What way you twist or turn it, it cannot not be a right angle triangle.
God damn it. Holy shit, dude. Just dumb.
Do you understand? It cannot not be a right angle triangle.
Yes, he thinks that he thinks that an angle must be part of a triangle. Yes, they're that fucking stupid.
Otherwise, it's not an elevation angle. This is so ridiculous that this has to be explained to people. But obviously, there's people out there who can't get this. You can't measure the elevation and
Oh, we can't get it?
ignore or deny the elevation. So this star here will appear to go to here when this person is 5,400 nautical miles away from it, right? Sorry, this would be nautical miles. 5,400 nautical miles, right? So when that star appears to be, or when the sun, whatever, appears to be 36 degrees to their horizontal, that means its GP point is 3,240 miles away, and it's the apparent height. If you want, right, if you use that, although it's not part of celestial navigation, you can give links to these sides. It doesn't make any difference. It won't give you the height of the sun or star because it doesn't. You can't give them a height. They don't adhere.
What? You can't give a height to something in the sky, Brian? Are you sure about that?
Here to terrestrial rules, right? But you can give them an apparent height. Right, the same thing though, like give them an apparent.
No, see, if you have measured an angle and you know the distance to the zenith, then you know the height of it, Brian. That's geometry. That's fucking geometry or trigonometry. See, if you know this and you know this, then you know this, Brian. You think different? So yes, you can calculate the height of the sun on a flat Earth by going to 45 degrees north latitude and measuring the angle, or you measure the angle to Polaris at 45 degrees. Then you know how far 45 degrees north latitude is from the North Pole. So you know how high the sun is or how high Polaris is. Now go out 10 degrees and I'll bet you money it won't drop by 600 miles. Or if you go out like 600 miles, it won't drop 10 degrees, Brian. It won't. I had to get my math right there. It just won't. It won't. I've proven this, Brian. See, my Polaris challenge proved this. The thing you were too chicken shit to take.
But what people don't realize is that, let's just say I'm measuring the angular height of a mountain, right? If I measure from here, and they say this is a mountain, I measure the angular height of it, right? And I don't know my distance to it. I don't know the height of the mountain. Does that mean that this is not then a straight line? That this is not a triangle? Does that mean because I've measured just the angle, does that mean that this is not a vertical? Does that mean that the triangle doesn't exist? No.
No, the triangle doesn't exist, Brian. You create the triangle. The triangle doesn't exist because you've taken an elevation angle, dipshit. God damn, dude.
That's a joke. Of course, it's always a triangle. It's an elevation angle. It doesn't matter if it's to a mountain or a celestial top of a mountain or a celestial body. It makes absolutely no difference whatsoever. Now, right, just to show, right, you can do this, right? Just so people are aware of this. You can do this, right? If I want to know the length of my hypotenuse, right, the length of this line, right, and the length of this one, I can use the length of this one here and the angle, 36 degrees here and 90 degrees here, to determine that that's 2,354 nautical miles. I said saturated earlier, I meant to say nautical. And this is 3,240 nautical miles. So then I can go, right, so what's the length of my hypotenuse?
Jesus
right?
fucking Christ.
I can go,
Hey, Rosinante.
3,
Hey, Sealess Raider.
240, right, squared, right, plus, where is it, 2354, 2354, are we, squared, right, equals 160,38916, right, and we just get the square root of that. It'll be 4,004.8615, blah, blah, blah. Point is, there is 4,004.86. Point is, now I can do that, right? And just because they don't do that in celestial navigation, that they only want this length here, that doesn't mean that they're not using a triangle. I can still do that and determine all the rest of the lengths of the sides of the triangle, all that other stuff. And I can even use it then at a later date, believe it or not. Right? The point being is that, as well as that, firstly, you don't need the zenith angle. You can use that process, but you don't need to. You just multiply your angle here by 60 and then subtract that from 5,400, same thing, right? So you don't need a zenith angle to determine the length of your adjacent. Now, if you want to use this or find this out, the length of this and the length of this, you then can. No one said you can't do it. No one said it's impossible. The point being is that it's not part of celestial navigation. They don't use those. They're not using this, and they're not using this. They're using this. Sorry, this here. Now you can determine them if you want and get an apparent height to the celestial body at that time. So if I took an angle of 36 degrees, right, on November the 11th, 2025 at 7 p.m. right, from whatever position, right? Then exactly 1 year later, right, if I'm out on a boat again and I see this exact star.
Say what? 1 year later?
Right, in the distance, at this exact date and time, I can then use the fact that it had a 2,354 nautical mile apparent height at that time, and I can use that as an angular size. I don't see why you wouldn't be able to use that as an angular size and gain.
Okay. How do you know where you are, Brian? How do you know where you are to know that you're looking at that same star at that same time at that same date? How, Brian? How? Jesus fucking Christ, he's dumb.
A distance to it, right, at the time. So if your angle was I don't know, to it was like 24 degrees or something, you could go, right, it has an apparent, at this exact time, it had an apparent 2,354 nautical mile height, right, and now my angle to it is 24 degrees, so that means that my adjacent length is blah, blah, blah. You can do.
Oh my God. Hey, Dan, how you doing? Oh my God, he's just dumb as fuck. He's just throwing numbers out. He doesn't know what he's fucking talking about. Doesn't have a fucking clue.
That, right? But they don't do that in celestial navigation. But all that aside doesn't matter because you can
You don't know what they do in celestial navigation, Brian, because you don't know how to do celestial navigation. The only thing you know about it is what 10th man has told you. or I'm sorry, what you've absorbed from him, because you aren't even smart. You aren't even as smart as 10th man.
Not have the lengths of these three sides, and you still have a triangle, a right angle triangle, because that's what an elevation angle is, right? That's why it's called an
An angle is a triangle. Heard it here first, people.
elevation angle and not just an angle, right? So as soon as this here leaves this point over here, so when this, right, star or whatever that would appear to be at the horizon, right, leaves this point here, as soon as that happens, right, as soon as that leaves the horizontal, immediately this is being created. So as soon as you start measuring even a quarter of a degree, immediately this vertical is part of that measurement. As that's what's been, or sorry, part of that, because it's been measured. It's literally there. That's
literally there. No, it's not, Brian. God damn. Okay, just show us any book, any textbook that proves you right, Brian. Go ahead and do that. Show us any textbook that agrees with you. I'll bet you money you can't.
what it is. So you can't deny this part and then claim to be measuring it. You can't do that. That is contradictory. It's illogical, right? As I said, they don't tell you when you go in to buy a car, oh, well, there's wheels on that car. Well, there better be. It's supposed to be a car, right? That's the point of it. It's a car. It has wheels. You don't need to be told that that car will have wheels. You don't need to be told that the pizza will have mozzarella on it. You don't need to be told these things. It's a given. These things are a given. Do you know what I mean? The same way as people who actually do science don't need to be telling people that they use scientific method. It's a given. These things are just a given. So this right angle triangle is a given for every elevation angle. Right?
No, it's not, Brian. Oh my God, you're fucking dumb.
It's a given, no matter what. Right? You can't measure elevation and ignore elevation. You can't measure altitude and ignore altitude. You can't ignore the vertical because that's what you're measuring. And then you can't be ignoring the opposite or saying there isn't an opposite. When that's the thing you're measuring, this vertical is the opposite. It is the altitude. It is the elevation. It doesn't matter if it's in degrees. A carpenter's set square is in degrees. It's still a triangle, a right angle triangle. Do you understand? There's no way.
You don't understand, Brian. You don't.
Around this. The bowlers must deny this because that ruins their ball outright forever. And as soon as flat earthers.
So just show us a book on celestial navigation that agrees with you, Brian. Just one book. You know, well, before we want to see the book before you deny everything that proves you wrong is fake. So you have to do that, right? You just can't take a book that 10th Man has read and he says, it shows a picture of the globe there, but that's fake. That's fake. But this part's real. This part is useful. But that part's fake where it shows you the curvature of the earth. That part's fake. See, that's all you know about celestial navigation is what that fool has told you, Brian. You're dumb as dog shit.
En masse cop on to what an elevation angle is and stop trying to help out the ballers and be idiots like the ballers are, then the problems will be far less for us. But unfortunately, flat earthers are listening to ballers, people who...
Yes, don't be idiots like the smart people. Don't be idiots like the smart people are. So funny.
Who either don't know and don't understand, or do know and do understand and are being deceptive. So either don't know and don't understand, so they're ignorant, and flat earthers are listening to them, or they do know and do understand and are being deceptive, and flat earthers are listening to them. Stop listening to the opposition. They're not your friends. Listen to yourself.
Yes, don't listen to the smart people. They're not your friends. You want to remain ignorant, so don't listen to any smart people. God, this is cult indoctrination right here. This is cult indoctrination, what he's doing right here.
Listen to look at what's.
Don't think about all the stuff you've learned in school and college and to get your PhD. Just listen to me. I know what's up. See, everyone has lied to you, but I'll tell you the truth. That's indoctrination.
It's actually real, because
that's called gaslighting. That's an attempt to make people question their sanity by telling them over and over again that everything they've learned is a lie. It's called gaslighting, Brian. Technically, that's illegal. That's considered emotional abuse.
If you're denying that this angle here, has nothing to do with this, then you're not measuring that angle. Nothing happened. You have a horizontal line and that's it. And as I said, right, you can determine the length of the other sides. Who cares? No one's using them, but you can. And you can then use it a year later. Who cares? You don't need to do that. That's why we have celestial navigation. That's the point of celestial navigation, that you can use the triangle without using trigonometry. Right? You don't use trigonometry with it, because all you have is the triangle. You don't have the lengths of sides, right? And all you want is this length, right? So, well, you do have the length of sides when you measure the triangle, but the point is that if you just...
So, on a flat Earth, you would have to use trigonometry. You could not use celestial navigation. So you're saying that all this is useless on a flat Earth. If you can't use this, right? If you can't use trigonometry, it's useless? Yeah, that's what you're saying, Brian. But you're not smart enough to realize it.
Using just trigonometry, and all you have is a 36-degree angle to the top of a mountain, and you don't know your distance from the mountain, you don't know what height the mountain is, then you can't do trigonometry. You can't do any of this. You can with celestial navigation after you've determined the length of this by multiplying your angle by 60 and then subtracting that by 50 from 5400.
No, only on a globe, Brian. Only on a globe. Because the relationship between distance and angle is a linear relationship. On a flat Earth, I've heard algebraic relationship. MC Toon called it an asymptotic relationship, which it is. So it doesn't work on a flat Earth, Brian. It doesn't work.
Once you have this, then you can determine the length of this and the length of this. But who can...
See, on flat Earth, perspective requires parallel lines to cross, Brian. That's how perspective works on a flat Earth.
We're not using them, but you can if you want. It's not that you can't do that. It's people need to understand the difference. You're using a right angle triangle.
Hey, Mule Fan, how you doing? Oh, Monkey's good. He's a boy. He's not a girl. He's been fixed.
Angle for your elevation /
and he's the best cat I've ever owned. I've owned 4, and he's the best cat. He's never, ever, ever knocked anything off onto the floor. He's never bit me. He scratched me once when I, tried to pick him up when he didn't want to be, but that was just him trying to get away. He's never taken a swipe at me. He's never bit me. He's never shit anywhere he's not supposed to. He's the best cat I've ever owned.
Altitude angle in celestial navigation, exactly.
He's an orange cat, so he's dumber than dog shit. But yeah, he's an awesome guy.
The same as you're doing it with surveying or anything else, right? You just, because you're using the celestial body to determine what you need to determine, you're not then looking to know the lengths of the sides. You just want the one side. But you can use them if you want. You can calculate them all. Calculate away to your heart's content. It's
No, just do it any way you want. Is that how it works, Brian? Just use angles if you want. Don't use them. Yes, he is, Mule Fan.
right? Calculate, do it all day
Thank you.
long.
Thank you.
Nobody cares. It's not that you can't do it, it's that it's not necessary to do. But that doesn't mean that this and this are not there.
You know what's funny is Brian charges $5,000 to debate him. That's it. That's his fee schedule. Is he charges $5,000 to debate him for what, 2 hours? I think he said. And but he knows so much about celestial navigation, right? Since he's an expert and all. And but he ran away like they all have from MC Tune's sextant challenge. Isn't that weird? How he's so desperate for money that he has to charge to debate him, but yet he runs away from a chance to make easy fucking money. Huh. That's weird, man. That's weird. I mean, if I knew as much as Brian does, if I knew everything about celestial navigation, and I knew the Earth was flat, then I'd take the challenge in a second, man. $10,000 fucking dollars. You know how much I could do with $10,000? Yeah, I'd take it in a minute. You know, if I was an expert. So why haven't you, Brian? Why haven't you? We all know why.
Like, get some cop on, flat earthers.
You know, we know why, Brian. You may be dumber than dog shit, but you have a self-preservation drive. You know, you don't want to humiliate yourself in public, so you just do little videos, you know. But you don't want to do that live.
Stop being boneheads. Stop listening to the opposition, because that's what you're being, and that's what you're doing. And it's only going to be to your own detriment, because you're the one's going to look stupid. I won't look stupid because I know what I'm talking about. Because
yeah, he knows what he's talking about. You know, when he says that an elevation angle is a triangle. You know, don't look stupid. Don't listen to the smart people, you know, that help educate you. Listen to me. I know what I'm talking about.
don't deny the thing I'm measuring. It's like measuring the height of a door frame, then denying the existence of the door frame. Why would you do that? It makes no sense.
We measure the Earth as spherical, but you deny the Earth. Right, Brian?
You know, it's stupid. But look, what can you do? That's what people are out there doing, right? But either way, doesn't matter. Your elevation angle, right, altitude angle, doesn't matter. It's always a right angle triangle. Because as soon as this right leaves that point. Right,
what is this point, Brian? What is this fucking point right here? You still haven't explained that, Brian. You still haven't explained this, what this point is. This here has nothing to do with this, man. Nothing. Neither does this. You're an idiot.
Right? Apparently, obviously, it's not really doing it. It's apparent, right, from
God.
the observer's position, and it ends up 1 degree above their horizon. Then straight away, right, instantaneously, right, and simultaneously, this is there. This exists. Sorry, that is.
No. See, Brian, when you're at the equator and looking north, Polaris is at eye level. So, due to the laws of perspective, that means that Polaris has to physically be at eye level, Brian. You think it is? You think if you called someone on the phone at the North Pole and said, "Hey, where's Polaris?" Is it like burning you? Can you touch it? What do you think they'd do, Brian? Think they might report you to the authorities? Or do you think they'd say, "Well, yeah, it's right here. I can touch it." You think they could do that, Brian? You think they could? See, that's perspective, Brian. Things that are at eye level when you're looking horizontally have to be at your eye level where they are physically. That's what you see on a flat earth. But you know why it's at eye level on a sphere? Because that's how it works on a sphere, Brian.
Exists. I've tried them out. That exists, and so this. I don't know how to make it any clearer to you. There's no way around this. It's always a right angle triangle because it can't not be. The same way as the car you buy from a dealership can't not have wheels and tires. Otherwise, you're not buying a car, are you? You know,
So you think a car without wheels is no longer a car? Is that what you think, Brian? That if I take the wheels off a car, it's no longer a car? Is that honestly what you think, Brian?
it's not a car. Even if it has tracks on
Wow.
it, it's not a car. At that point, it's more or less a tank. Point being is that if it doesn't,
Wow.
like, no one, the dealership doesn't tell you, oh, there's seats in that. Yeah, it's a car. There needs to be. It's a given. So that's
Good
hopefully
God.
this will somehow get the point across that you can determine the lengths of the sides and you can do this, that, and the other thing, but you don't need to. And you also don't need any zenith angle. You don't need that. Just multiply 36 by 60 and then subtract it from 5400. There's your length. No need for a zenith angle. You don't need it. You can use it if you want, and I know why they use it, but it's not necessary. Right? There's globe nonsense going on. Even though it's the zenith distance and zenith angle are right angle is another right angle triangle and a straight line distance. They hijack that. I won't go into it right now. Either way, right? If you say that when you're measuring an elevation angle that it's not a right angle triangle, then you're wrong. You're just wrong. There's no if, buts, or maybes about it. You're just wrong. You know, it's like trying to deny the wall you're painting exists. This wall doesn't exist that I'm painting. How can you be painting it if it's not there? I don't know. Anyway, thanks
God, what a dumb fuck. Oh my God, what a dumb fuck.
for watching.
Jesus Christ. And he just loves it. He's got some sort of fucking humiliation kink, like they all do. They just love humiliating themselves in front of smart people. Hey, look how dumb I am. Laugh at me, world. I love it. Jesus Christ, what a fucking human sand trap. Anyway, thanks for watching, guys. That's all I have for you. It was a short one tonight. And we'll be back. I know MC Tune's on later. It's Tuesday, so this is his day. So I won't belabor you no longer, brethren.